Okay, today we are doing section 7.3 on ellipses. An ellipse is kind of an elongated circle. If you want to learn more about it, I actually posted a page that shows how you can draw an ellipse. Let's look at one of the basic formulas for an ellipse. There are other varieties of formulas that we'll talk about soon. Let's just focus in on this particular one. They're all pretty much the same. This particular formula is only if the center of your ellipse is at 0, 0. Or the origin. Okay, let's draw a picture of what this ellipse would look like and what all the parts are. Oh, not nearly as good as I would like it to be, but you know how it is. Okay. This point and this point here are known as the vertices, or singular is vertex. This point is located at a, 0, and when I say a, I'm talking about the square root of the number that's located here in the formula. We'll do an example in just a minute. This point here then would be located at negative a, 0. Okay. This point here doesn't really have a name, but that point is at 0b, referring to the square root of that number right there. And this number right here, which should be symmetric to that one, but my drawing isn't very good, should be at 0, negative b. Okay? If the center were anywhere but 0, 0, we would call it HK, just like we did with circles. Let's learn some other words here. The distance from one vertex to the other is called the major axis. Is from one... Oh, I don't know what I'm writing. From one vertex to another. And its length is 2 times a. Right? Okay, so there's that. And the minor axis is the other direction. So the length of the minor axis, if you need it, is 2 times b. Okay, but we don't deal with the major and minor axis very often. Okay, one of the crucial things to understand for an ellipse, if you're going to actually draw one or apply it to things like orbits of planets and stuff like that, are what's known as the foci, which is plural for focus. So every ellipse has 2 foci. So here's one focus, and here's another focus. Okay? The foci are located at plus or minus c from the center of the graph. Now notice how there's no c in the formula, so the focus itself is not listed in the formula. Okay? But you are going to need to know how to find c. c is related to a and b by Pythagorean Theorem, and this is where you need to make sure you're not so caught up in Pythagorean Theorem being a squared plus b squared equals c squared that you can't figure this out. Remember, Pythagorean Theorem generally relates to a right triangle, and in a right triangle, what we refer to as c is the hypotenuse, or the longest side. If this point is at c, 0, this point's at negative c, 0, would c be the longest side in this situation? Of course not. A is going to be the longest, and b and c are always going to be shorter than a for an ellipse. So b squared plus c squared equals a squared. So therefore, if we want to find c, what we do is a squared minus b squared, and then square root that. And that will give us the location of c, or our foci, for the problem, if we need to know those.